Okay, so remember on your test you were given a rational expression like this, and you were asked to find the domain. How'd you find the domain of this rational expression? What'd you do first? You had to find your restrictions. Very good. And your restrictions, remember, would be where the denominator is 0. Okay, this was in your test. And so where would this denominator be 0? When x is what? Negative 1/2. Negative 1/2. So that would be your restriction. So we talk about vertical asymptotes, we're going to use that idea. All right, so first of all, you got to find your restriction. So let's talk about the restrictions. The restriction here, now remember the restriction is or the x values that you cannot use. So I have this rational function, so this rational expression that I'm pointing to, I can never have what number in the denominator? 0. I can never divide by 0. So I got to figure out where's this denominator equal to 0. Remember doing that on the worksheet? I think that was one you had to turn in last week or so. So if you solve for x, I get 2x equal negative 1, so x is negative 1/2, right? So that's your restriction. So x cannot be negative 1/2. So in terms of the domain, what you did was you said that my domain would be any number but what? Negative 1/2. And so you wrote as an interval. Remember writing as an interval? There was one part where you wrote as an interval, I think. So what we did there was we said negative 1/2. We put an x there. And you said the domain was from negative infinity to negative 1/2. Union negative 1/2 to infinity. Remember that? Mm-hmm. Another way you wrote the domain was like this. Or you could have said the set of x's such that x does not equal what? Negative 1/2. All right, so remember there were a couple of ways in which you could have written the domain. Now, the one in your worksheet, I also made you say the set of x's such that x is a real number and x does not equal negative 1/2. Remember doing that? Or it might have been in 99. Was it in here? Okay, then it wasn't in here. It was in Math 99 then. All right. But you did that last semester, though, because we did it in Math 99. So this is how you would write the domain. Either an interval or here, but in my math lab, this is the one they're going to use, this interval. I mean, the set right here. Well, it turns out that in terms of a rational function, this restriction is your vertical asymptote. So your vertical asymptote is always going to be your restriction. So your vertical asymptote, asymptote, vertical asymptote is going to be your restriction. So I'm going to start graphing this. Although in your test you're not going to graph, you're just going to tell me the vertical asymptote and horizontal. On your final, they may ask you to graph. So you need to still be able to do it, but not on your test. I won't ask you that. So your vertical asymptote indicates that that's not part of your graph. That x value is not part of your graph. It's not part of the domain. So when you take out your grid paper, you're going to draw a vertical line, just like you did with the axis of symmetry. It'll be a dotted line, just like you did with the axis of symmetry. It'll look just like that parabola, or the line, a dotted line. So your vertical asymptote is going to be x equal negative 1/2, though. All right, listen carefully. Your restriction, you said x cannot equal negative 1/2, right? Your vertical asymptote, though, you're going to say x equal negative 1/2. Just like your axis of symmetry was x equal, right? Your vertical asymptote is what kind of line? Vertical line. You name a vertical line using x equal. Okay? Don't confuse this with this. This says that x value cannot be what? Negative 1/2. This here says, what is that line? Well, you name a line with x equal. So what is that line? Negative 1/2. All right, so here's what you're going to do, though. So negative 1/2 is between 0 and what?
1.
Negative 1. So I didn't, it's not very spaced far apart, so it'll be difficult somewhat to see. But let's see if I can, maybe on here, extend it a little bit further. All right, so negative 1/2 is right here. See what I'm doing? You see what I did, right? Okay. All right, so draw a vertical line, vertical dotted line at negative 1/2, just like that. Okay, any question at this point? So you know how to find the vertical asymptote? Your vertical asymptotes, first of all, you have to find the restrictions. What makes the denominator 0? And those are your vertical asymptotes. And you got to draw your vertical asymptotes. You must draw your vertical asymptotes. And how do you draw your vertical asymptotes? A dotted line. Vertical dotted line. Okay. Now, let's talk about the horizontal asymptote. So the vertical is easy because you've had that already. You know how to find them. You've had that experience. Let's talk about the horizontal. The horizontal asymptote involves the word degree, which we just did. So you have to remember the idea of degree. Okay, so listen carefully to this. Okay, finding the horizontal asymptote. All right, finding the horizontal asymptote. All right. Okay, let's look at part A. Part A says this. If the degree of the numerator, is equal to the degree of the denominator. All right, so if the degree of the numerator is equal to the degree of the denominator. In our example, what is the degree of the numerator? 1, good. How many terms are in the numerator? 2. What's the degree of that first term?
1.
What's the degree of the second term?
0.
0. What is the degree of the denominator? 1. What's the degree of the first term?
1.
What's the degree of the second term?
0.
0. So the degrees are the same, right? Okay, so in our example, the degrees are the same. Okay, so if the degrees are the same, then the horizontal asymptote now remember, a vertical asymptote is what kind of line? A vertical. And how you name a vertical line? X equal. A horizontal asymptote is what kind of line? How you name a horizontal? Y equals a number. So your horizontal asymptote will be y equals, okay, now listen carefully. The leading coefficient of the numerator divided by the leading coefficient of the denominator. So the leading coefficient of the numerator divided by the leading coefficient of the denominator. Now you remember that leading coefficient. If you put in descending order, if you put your polynomial in descending order, the leading coefficient is the coefficient of the largest degree term. Okay? The leading coefficient is the coefficient of the largest degree term. How many terms are in that polynomial in the numerator? 2. First term, second term. Which one is the largest degree term, first or second? First. What is that leading? Well, what is that coefficient?
1.
What is the coefficient? 4. Okay, 4 divided by. Look at the denominator. What do you think is the leading coefficient in the denominator? 2. What's 4 divided by 2? 2. So my horizontal asymptote is y equals 2. Your horizontal asymptote is y equals 2. Okay? Before we go any further, let's look at these. Let's look at 2 examples without going any further beyond what we just did. So look at these functions. Okay, suppose I had this function. Number 1, f of x equal 7 minus 2x squared plus 6x divided by x squared plus 7. Ooh, let me change it. X squared minus 9. Sorry, x squared minus 9. Okay. 2 things we know how to do. We know how to find the vertical asymptote, and now for this one here, I think you know how to find the horizontal. Let's talk about the vertical. Find vertical asymptote. Now I'm going to say this: you can have more than one vertical asymptote. So I'm going to put this in S as singular or plural. But there can only be one horizontal asymptote. How do you find the vertical asymptotes? From your previous experience, how do you find the vertical asymptotes? You got to find your restrictions. So I'm going to set the denominator equal to 0. Now, what kind of equation did I just write? Quadratic. How do you solve this quadratic equation? You can use a square root property because the x term's missing. I would not use quadratic formula. It is easier to use either factoring here or square root property. Factoring would involve you saying x minus 3 times what? X plus 3, because this was the difference of 2 squares. And so then you use a zero factor property. So x minus 3 equals 0, x plus 3 equals 0. So what are your restrictions? 3 and negative 3. Or you could have used the square root property, meaning this. I could have brought 9 over, the constant term, and then do what to both sides? Square root, plus or minus. And so I get x to be plus or minus what? 3. So it didn't matter which one you used. But you notice there are how many restrictions? 2. So there are how many vertical asymptotes? 2. So your vertical asymptotes, I'm gonna call it VA. You would say x equal though. X equal what? You gotta name them separately. X equal 3, and the other one is negative 3. So those are your vertical asymptotes. All right, let's talk about the horizontal asymptote. Let's find the horizontal asymptote. What do you notice about the degrees of the numerator and the denominator? Okay, what's the degree of the numerator?
3.
What? What is the degree of the numerator?
2.
2.
Okay.
Degree is 2. There are 3 terms. I don't know if that's what you were referring to when you said 3. There are 3 terms, but that's not what the degree is. What is the degree of that first term?
0.
What's the degree of the second term?
2.
And what's the degree of the third term? So what's the degree of the polynomial? 2. The largest degree term. What is the degree of the denominator? 2. What do you notice about the degree of the numerator and the denominator? They're the same. So we know that if they're the same, then the horizontal asymptote is going to be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. What do you think is the leading coefficient of the numerator? -2. It's the coefficient of the largest degree term. Isn't that where you got your largest degree term? What's the coefficient? -2. So don't say 7. It's not the first term, right? It's whatever the largest degree term is, the coefficient of that. And then what do you think is the leading coefficient of the denominator?
1.
No, 1. That who said -9?
I did.
So that's your largest degree term here. So that coefficient here is 1. So what is your horizontal asymptote? Y equals -2. Okay? All right, number 2. G of x equal x squared divided by x times x minus 3. G of x equal x squared divided by x times x minus 3. Okay, first thing is to find the vertical asymptotes. So let's just say VA. How do you find the vertical asymptotes? Find the restrictions. And how do you find the restrictions? Set the denominator equal to 0. So I'm setting my denominator equal to 0. X times x minus 3 equals 0. What kind of equation did I just write? No, that's not linear. What kind of equation is this? Quadratic. If you distribute, don't you get x squared minus 3x? But what do you notice about this quadratic equation, though? It's already factored. So how do you find your restrictions? Set both of them equal to 0. The zero factor property. So my two factors are x and x minus 3. So x equals 0 and x minus 3 equals 0. So this one already has x by itself, so there's one of my restrictions. What's the other restriction? 3. So how many vertical asymptotes are there? 2. They are x equals 0, and what's the other? X equals 3. Okay? All right, you got to remember some things you had factoring in your test. All right, now, horizontal asymptote. So to find the horizontal asymptote, that's where you look at the degrees first. What is the degree of the numerator? What's the degree of the numerator? 2. Not 1. Why you said 1? Tell me where that 1's coming from. There's only one term, right? So the degree is just that exponent. What is the degree of the numerator? 2. What is the degree of the denominator? 2. Because if you look at the denominator, x times x minus 3, and if I go ahead and distribute, that becomes x squared minus 3x, doesn't it? Yes. So the degree is also what? 2. Okay. So what do you notice about the degrees? They're the same. So the horizontal asymptotes, and notice the degrees are the same. Degree of numerator equals degree of denominator, right? Which is 2 in both cases. So since the degrees are the same, we got to look at the leading coefficient. So y will equal, what is the leading coefficient in the numerator? 1. You see, that's the 1 right here, right? All right, now let's talk about the denominator. What is the leading coefficient of the denominator? 1. See how it's already factored here? What I would have done is I would have multiplied out first and then used this one. So what's that leading coefficient? 1. And so what is my horizontal asymptote?
1.
Y equal 1. Okay? All right. So that's how you find a horizontal asymptote where the leading coefficients are the same. Okay? Now let's go back to the first one we were doing. This one here. Right here. And let's continue graphing. So we've graphed the vertical asymptote. So that's this dotted line. That's this dotted line. Okay? Then let's look at the horizontal asymptote, which is y equals 2, right? You agree? You do this. You see what I just did? You'll see what I just did, right? Okay. So you have the vertical asymptote, which is a vertical dotted line. And I have the horizontal asymptote, which is also a horizontal dotted line. But notice it went through the y-axis where? At 2. Because y equals 2 is that's what the line looks like. Okay, any question at this point?
I thought we just done the horizontal isotope as 1.
Oh, girl, we're going back to that previous problem we had.
Oh. I'm a slow writer. I'm always 2 steps behind.
Sometimes you're 7.
I won't argue with that.
All right. Okay, now, when graphing, on your final, they have this on your final, this won't be on test 4. On test 4 will be what we just did. Find the vertical, find the horizontal. So you have to graph your vertical. You're going to graph your horizontal. All right, now, here's what else you got to find. You got to find your Y-intercept. So let's find the Y-intercept. To find the Y-intercept, what do? Let x equal 0. Just like you did with the parabolas. Find the Y-intercept, find the X-intercept. Okay? All right. So to find the Y-intercept, you let x be 0. So if I go back to my function, wherever we see the variable x, what do I plug in? 0. So I get y will equal 4 times 0 plus 1 divided by 2 times 0 plus 1. What's the numerator? 1. What's the denominator? So what's my y-intercept? 1. So the graph crosses the y-axis where? At 1. All right, so plot that point right here. See right here? At 1. So put a dot on the y-axis at 1. That's your y-intercept. Okay? Now let's find the x-intercept. Let's find the x-intercept. The x-intercept. To find the x-intercept, you let what? Be 0. Let y equal 0. Well, y is what part here? Of x. So just like we did the quadratic, the parabolas, do the same thing here. Quadratic functions, you do the same thing here. Set that equal to 0. Set that equal to 0. So I get 4x plus 1 divided by 2x plus 1 equal 0. Okay? Now listen carefully to this. You remember in one of your courses previously when you had something like this? X divided by 5 equals 2/3. How could I have solving for x without having to find the LCD? What could I have had done? Cross multiply. Because you have a proportion. You have a fraction equal to a fraction. So you would have said 3x equal what? 10. So x is 10/3. You have a proportion here because I can write 0, 0 over what? 0 over what? 1, right? 0 over 1. And so I cross multiply, which knows what happens when I cross multiply. This denominator times 0 becomes what? 0. And 4x plus 1 times 1 becomes 4x plus 1. So I want you to notice something. So this equals this. When finding the y-intercept, all you got to do is find out where the numerator is what? 0. Because when you cross multiply, that's what you have. The numerator equals what? 0. This times this is this. This times this is this. Remember, all we do is cross multiplying based on what we've learned in a previous course. And notice I solved this linear equation. So I get 4x equal a negative 1. So what does x equal? Negative 1/4. That's where the graph crosses the x-axis. Okay, so watch this. So I'm gonna put a point on the x-axis. You can't see it very well here. Let's see. Okay, so do y'all agree? Do y'all agree that x equal negative 1/4 is about here? Right here, right? All right, so you can't see it very well. But here's the idea now. You see those asymptotes? So let's talk about asymptotes. Whenever you're graphing rational functions, your graph will never cross the vertical asymptote, never, because that's where it's undefined. So it cannot. There are times when the graph may cross the horizontal, but it will never cross the vertical, okay? For us right now, when we graph this, the graphs that we do today and next class period, for the most part, will not cross the horizontal. Will the graph ever cross the vertical, yes or no? Will the graph ever cross the vertical? No, because that's where it's undefined. The graph may at times do, though, cross the horizontal, but for us today it won't. So here's the idea. You see how I have 2 points here that are between this vertical and this horizontal? All right, so the graph does something like this. It gets closer and closer as x gets bigger and bigger. The graph gets closer and closer to this horizontal asymptote, but doesn't cross it. And as you go towards the vertical, it gets closer and closer to it, but doesn't cross it either. So that's what that part of the graph looks like. Okay? So as you get more experience with this, it gets a little bit better. So that's why on the next test, I'm not going to give you one that you have to graph. All I'm going to ask you is what's the vertical asymptote and what's the horizontal. So on this side of the, so you see this vertical asymptote? How many vertical asymptotes were there? How many vertical asymptotes were there? How many vertical asymptotes were there in this graph? 1. You only have one vertical dotted line, right? There's only one. So your horizontal asymptote, your graph is going to have 2 parts. One on the right, one on the left. I've already drawn the graph on the right. Now I've got to draw the graph that's located where? On the left. Okay, now listen carefully to this. This will help you, but we're going to look at it another way as well. Now remember, your graph always oscillates towards the asymptotes. See how this goes here and this goes here? Okay, or I could have a graph that did this instead. See this? But mine did this one. Can the other side do this?
No.
Why not? There's a very easy reason. Because it would cross the x-axis. But how many x-intercepts were there? Just one. We already found it. So it cannot do this one because that would mean that would be another x-intercept. So the graph has to be on top. So either the graph is above the horizontal or it's below. Which one is it? Above. So it has to do something like this. And all you do is the t-table, watch. Give me an x value to the right of the vertical asymptote. Let's choose a different one. Negative 3?
Yeah.
Negative 3. So I go back to my function, just right here, wherever we see an x, what I plug in. The reason I didn't want to use negative 1 is because it's too close to the vertical. So I want to use something a little bit further away. So if x is negative 3, I get 4 times negative 3 plus 1. Remember, wherever you see an x, you plug in negative 3. Divide by 2 times negative 3 plus 1. What's 4 times negative 3? Negative 12 plus 1.
Negative 11.
Okay. What's negative 2 times negative 3?
Negative 6.
Plus 1.
Negative 5.
And a negative divided by negative is a positive, so it's about 2 2/5. So your y value is about 2 2/5. 2 1/5. I'm sorry. 5 and 11 is how many? 2 with a remainder of 1. So where is negative 3 and 2 1/5? That's about right here. So where's that point located? Above or below the horizontal? Above. So your graph's going to do this without crossing the asymptotes. So that's your graph. You're done. That's how you graph it. We're going to do some more. You get better with this as the more you do. But the point is this. First of all, you got to find the vertical asymptote and the what? Horizontal. That's the first thing you have to do. And on your test, I'm going to ask you on test 4 just to find the vertical and the horizontal. Okay? Now we're going to come back and do some more with the graphing next class period. So if you didn't get this right away, don't worry about it. We'll do it again next class period. Okay? Now let's look at this one now. Okay, watch this one. Okay, now let's suppose I had this. This would be number 2. G of x equals let's say I had x plus 1. Let's just do this. 5 divided by x plus 2. Let's make it simple. 5 divided by x plus 2. All right, 5 divided by x plus 2. Okay, listen carefully to this part. The vertical asymptote is the easiest to find because it has to do with your restrictions. It's always the easiest. Okay? What is my restriction? X can equal what? Negative 2. Once you find your restriction, you know your vertical asymptote. What's my vertical asymptote? No. X equal negative 2. That's your vertical. So how many vertical asymptotes were here? 1. Okay. Let's find the horizontal. Now, all we know so far was this, based on our knowledge about horizontal. Are the degrees the same? No. What is the degree of the denominator? 1. What is the degree of the numerator? 0. Okay. All right. So when we did this earlier, if I can find it. This is right here. So find the horizontal asymptote. Part A, if the degree of the numerator is equal to the degree of the denominator, we saw what to do. In this case, are they the same?
No.
No. So part B. if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always going to be this: y equal 0. Y equals 0. So if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will always be y equals 0. Now, if you think about y equals 0, what part of the coordinate plane is y equals 0? Which axis? No, y is vertical. This is horizontal. The x-axis. So x-axis. Okay? So if the degrees are the same, you know what to do. You take the leading coefficients. If the degree of the numerator is less, then it's automatically y equal what? 0. Okay? All right. So what we're doing in this course is looking at the possibility where they're the same or the possibility where the degree of the numerator is less than. We're not going to look at a possibility where the degree of the numerator is bigger than. That's a different kind of asymptote. All right. Now, here's what I'm going to ask you. We're going to come back next week and graph this one. On your test, though, make sure you can do something like this. Number 1, I'm going to ask you to find the vertical asymptote. Could be more than one. And the horizontal asymptote, which for us will only be 1. If a function has a horizontal asymptote, there's only 1. Can I have more than 1? All right, g of x equal x plus 2 divided by 2x squared minus 3x. Ooh, yeah, that's fine. 2x squared minus 3x. I keep forgetting I want to do the vertical as well. So I have to make the denominator easy. All right, here we go. Which one do you think for you, now that you know something, is easier to find in this case, the horizontal or the vertical? You think the vertical? Okay. I thought you would have said the horizontal because what do you notice about the degrees? The degree of the numerator is less than the degree of the denominator. So the horizontal asymptote is right away what?
0.
Y equals 0. All right. But how do you find the vertical? Okay, so we find the restrictions first. And to find the restrictions, I take that denominator and set equal to 0. What kind of equation did I just write? Quadratic. So how are you going to solve this quadratic equation? I'm not going to use a formula in that one. You can factor out an x, right? The GCF is x. So you get x times what?
2x minus 3.
Now, you could have used quadratic formula, but you're supposed to recognize, hey, the GCF is x, and then right away I can use the zero factor property. So what do I set equal to 0? X, and what else? Yeah. So here, x is already by itself, so I found one of my vertical asymptotes. Here, 2x is equal to 3, so what's the other vertical asymptote? 3/2. So those are my restrictions. So I found my vertical asymptotes. My vertical asymptotes are x equal 0 and x equal 3/2. So those are your vertical asymptotes. Now let's talk about the horizontal asymptote. The horizontal asymptote, you got to look at the degrees. The degrees. What is the degree of the numerator? 1. What is the degree of the denominator? 2. So since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is just y equal what? 0. Which happens to be which axis? The x-axis. And when we graph, we're going to put a dotted line on the x-axis. That's the way we're going to do it. But all we're doing at this point, since because of the time, is we're just going to, given a rational function, just make sure you can find the vertical and the horizontal asymptotes. Let's look at one more. Let's look at number 2. Number 2. Suppose you had this. F of x equal 3x squared minus 7x divided by, divided by x squared plus x minus 12. So 3x squared minus 7x divided by x squared plus x minus 12. I want you to find the horizontal asymptote and the vertical. How many are for us? Because we're not talking about that other asymptote where the degree is bigger. For us, how many horizontal asymptotes are we going to have? No, how many horizontal? Just one. You can only have one. Which one's easier to find in this case, the horizontal or the vertical? Horizontal is the easiest to find. In fact, it's easiest to find in all cases, probably. Because what do you notice about the degrees of the numerator and the denominator? They're the same. They're both 2. So to find the horizontal asymptote, it's just the quotient of the leading coefficients. What's the leading coefficient in the numerator? Is it because it's listed first? No, it's because it's the coefficient of the largest degree term. What is the degree of the denominator? I'm sorry, what is the leading coefficient of the denominator? 1, because that's your largest degree term. So it's 1. So what's my horizontal asymptote? Y equal what? 3. That's the easiest to find. Your horizontal asymptote are usually the easiest to find. Let's look at the vertical asymptote. How do you find the vertical asymptote? Find the restrictions. How do you find the restrictions? Set the denominator equal to 0. What kind of equation is this? Quadratic. How are you going to solve this quadratic equation? Yeah, it's factorable, but if it wasn't factorable, then the only other choice would be to do what? No, not square root. Quadratic formula. You can't use the square root here, the square root properly right away, because there's an x term. But it's factorable. So x, 4, 3, and I think 4 is positive and then 3 is negative. What's the next step? Yeah. So what are your vertical asymptotes? X equal negative 4 and positive 3. All right, so that's how you find them. Now, next class period, we're going to actually look at the graphs, because there may be one in your final where you have to graph. Okay, so y'all can do this next week in terms of finding the horizontal and vertical, right? So I'm going to give you a vertical, I'm going to give you a rational function, and it's going to say state the horizontal and say the horizontal asymptote and the vertical will be in terms of multiple choice. It'll be part of a multiple choice question. Okay? All right. Now,